Today we're going to talk about solving absolute value inequalities, which basically puts together the ideas of absolute value equations with inequalities. So, take out your notes, you can flip to the last page in your notes packet. We're going to use the same examples from your notes packet so you can record those. Okay, so first thing we want to do is write down the steps. So they're very similar to solving absolute value equations. The first thing we want to do is get the absolute value alone. And just like when we're solving absolute value equations, we do want to check and make sure that the absolute value is not negative, or there's not a negative on the right-hand side. That's when we're going to have those special cases. So over on this right-hand side, whether it's a less than, greater than, you want it to be positive. If it's negative, it'll be a special case. And we'll look at what those look like in some of these examples. Okay. Once you have the absolute value alone, it's greater than, less than equal to, greater than equal to a positive, you're going to split the absolute value into two problems. Now, what you need to remember is for the negative case, you're going to flip the inequality sign. So if for the positive case it's a greater than, for the negative case then it has to be a less than. So if it's a negative, you're going to have to flip that inequality sign. The other thing you need to do is look at the positive case. If it's a less than and less than, it's going to be an and. If it's a greater, meaning it's going to be an or. Because we know that if we have two inequalities, then we have to connect them with a sign. And then finally we're going to solve. Okay, so let's take a look at some of these examples in our notes packet, actually apply these rules and solve some absolute value inequalities. Okay, so this is the first example that you have in your notes. The absolute value of x plus 5 plus 1 is greater than or equal to 7. So the first thing we want to do is get that absolute value by itself. So we got to get rid of this 1. So I have the absolute value of x plus 5 is greater than or equal to 6. So I'm checking that 6 is positive. I'm good to go. So I'm just going to split this into two cases. X plus 5 is greater than or equal to 6. X plus 5, here comes the important part. You have to flip that inequality sign. Less than or equal to negative 6. Now I got to figure out what word goes in between these, an and or an or. So I'm going to look at that positive case. That positive case has a greater than or equal to sign, so it's going to be a greater, so it's going to be an or. So I'm going to solve each of these individually. X is greater than or equal to 1, or x is less than or equal to negative 11. So this should be my solution. I'm just going to graph it on a number line to make sure that there's nothing funky going on with this. So I'm going to graph the first one in one color. So I'm going to do greater than or equal to 1, so it'll be a closed circle going to the right. I'm going to pick another color for the other one. Closed circle on negative 11 going to the left. So I want everything that's red or green on my final number line. So that's everything that's less than or equal to negative 11 or greater than or equal to 1. So it looks like a typical or. If I was writing this in interval notation, I could do negative infinity to negative 11. And then, but I would want to include negative 11, so I want a bracket on the 11. And then from 1 to infinity. Okay, let's take a look at that second example. Okay, so these steps are still the same. We want to get that absolute value by itself, so we're going to get rid of this 2. So So I now have the absolute value of 2x minus 5 is less than 5. I want to check and make sure that that 5 is positive. And it is. So we're good to go. We're going to split our cases. So we have 2x minus 5 is less than 5. Less than is going to be an and then 2x minus 5. I got to flip that inequality sign for the negative case. Is greater than negative 5. So I'm going to solve these individually. So I get x is less than 5 and x is greater than 0. So we're just going to graph these, make sure that there's nothing funky going on, and check our answer. So our number line, we got to have a 0 and a 5. Graph 1 in one color. So less than 5, open circle on 5 going to the left. Greater than 0, open circle on 0 going to the right. So I want everything that's blue and green, or everything that's on both of these, so only where they overlap. So that's between 0 and 5. In interval notation, that would be 0, 5. So we could write our answer in either way, with the inequalities or the interval notation, and then this would be our graph. Third example. Okay, here's our third example, and we want to remember from when we did the absolute value equations that the 3 is being multiplied and the 5 is really being added. So I really, doing SAD map, have to get rid of the 5 first. So I'm going to subtract the 5. So I get negative 3 times the absolute value of x minus 1 is greater than negative 30. Now I'm going to divide by negative 3. Now I have to keep in mind, because this is inequality, all rules of inequalities apply. So since I just divided by a negative, I'm going to have to flip that sign. So I actually have the absolute value of x minus 1 is less than 10. And it's now positive 10, so I can go ahead and split those two cases. So x minus 1 is less than 10. Less than is going to be an and. X minus 1 is greater than negative 10. So I'm going to solve these individually. X is less than 11, and x is greater than negative 9. We'll just graph these, check our solution. So create my number line. I'm just going to do it up here in the corner because I'm kind of out of space. I need a negative 9 and an 11. So less than 11, that's going to be an open circle on 11 going to the left. Then pick another color here, greater than negative 9, open circle on 9 going to the right. I want everything that's red and green, so that's just going to be in between those two. So it looks like a typical and. In interval notation, we'd write negative 9, 11 with 2 parentheses, because neither of them are included. Finally, we'll take a look at our fourth and final example. We've got negative 2 times the absolute value of x minus 3 is less than 10. So first thing I got to do is get rid of that negative 2, and again, I'm dividing by that negative, so I'm going to have to flip that sign. Absolute value of x minus 3 is greater than negative 5. This negative should jump out at us. This is going to be a special case. So because it's just not an equal to sign, sometimes it could be no solution, but other times it could be all real numbers. There's multiple types of different special cases. So we have to think about what we know about absolute value. We know that absolute value is always positive. So we have a positive, and then we have a positive is greater than a negative. Well, when is a positive number greater than a negative number? Always. So this is actually all real numbers. So if I was doing a number line, I would shade the whole thing. This would be a solution. Every number from negative infinity to infinity would work in this inequality. If it was the other way around, so for example, if I had the absolute value of x minus 3 is less than negative 5, this would mean that the positive is less than the negative. So if it's a less than sign, then it's going to be no solution, because a positive can never be less than a negative number. So if a positive is less than a negative, then it's going to be no solution. If a positive is greater than a negative, then it's going to be all real numbers. Greater than, equal to could also fall into the category of greater than, and less than, equal to could also fall into the category of less than. So if it's less than, it's no solution. If it's greater than, then it's all real numbers. That wraps up absolute value inequalities.